Hello, I'm putting together this little video to act as a resource so that you have a video of me working through an example of factoring with fractions and then using that factoring to graph a quadratic where the leading coefficient is not 1. So here we go. You'll notice that there's a number out front. When there's a number out front, we need to divide it out so we can use our old techniques of multiplying and add just like we always did before. So if there's a 2 out front, I'm going to divide out the 2. So I've got y equals 2. When I divide out the 2, that 3 becomes 3 halves x, and that minus 5 is now minus 5 halves. My goal then is to find two numbers that multiply to be negative 5 halves, add up to be 3 halves. If I use a table to help me, I know it has to add up to be 3 halves, and the add up piece was always the combination of these two. So these have to be half x's. They have to add up to be 3. Maybe they're 1 and 2, 3 and 0. They could be positive and negative too as well, 6 and negative 3. But they need to multiply to make negative 5 halves. But you'll notice this, when these halves and halves multiply, they're going to make fourths. This term is not currently in terms of fourths, so I need to rescale it. The top needs to be multiplied by 2 and the bottom needs to be multiplied by 2 because it has to multiply to be negative 5 halves, but halves and halves is going to make fourths. So this is going to end up being x squared plus 3 halves x minus, this is going to be then 10 fourths. Now I need two numbers that multiply to make negative 10 fourths, add up to be 3 halves. But the halves and halves have already been taken into account of, and so have the fourths. So I really just need to focus on the top part. What two numbers multiply to make negative 10, add up to be 3? Those numbers are going to be 5 halves and minus 2 halves. Let's check. 5 halves minus 2 halves, when I add them, plus a negative, it makes 3 halves. When I multiply, 5 times negative 2 makes my negative 10. Halves and halves make fourths. They do exactly what I needed. So my factoring is 2x plus 5 halves, x minus 2 halves, but 2 halves is really 1. So I write it like that, and it's factored. I can now use the factoring to find the zeros. The zeros are also just another name for the x-intercepts. We call them that because they're the x values that make y equal to 0. So I set y equal to 0, and now I'm going to solve. But because of my factoring, I've already done all of the hard work. I know that one of these things has to multiply, or has to be 0 when I multiply them and make 0. So either maybe this part is 0 or this part is 0. If it's the blue part, I would get 1. If it's the red part, I get negative 5 halves, which is really negative 2.5. So I'm going to plot those 2 points. I've got positive 1 and negative 2.5. Now I need to find the vertex. The vertex is always halfway between my x-intercepts. How do I find halfway in between? I average. So negative 2.5 plus 1 divided by 2. That's going to make negative 1.5 divided by 2, which is negative 0.75. So I have half of my vertex right now. I know it's at negative 0.75. If you want to, you can put a dashed vertical line at that value, and we call that the axis of symmetry. It should be halfway between my values for my x-intercepts, and it looks like it is. If I have the x-coordinate from my vertex, how do I find the y-coordinate? I substitute this value in my equation in for x. In class, we've been doing that by storing that x-coordinate in for x in my calculator and then typing in the equation. So I will type in, once the calculator loads, negative 0.75, and I'm going to store that for x. Then I'll type in my equation of 2x squared plus 3x minus 5. So like I said, I will type in negative 0.75, store it for x, and hit enter. And then I type in my equation, 2x squared plus 3x minus 5. All I'm doing is substituting that value in for x, so it returns the y value, and that gives me negative 6.125. I'll show what the steps here that the calculator did. It just substituted negative 0.75 in for x, and then evaluated, and you end up with negative 6.125, which is an eighth. So negative 6 and an eighth. So when I plot this, it'll be right down here, just below the y value of negative 6. My last point is my y-intercept. The y-intercept is when x is 0. If I put 0 into my original equation, this part will become 0, this part will become 0, and I get 0 plus 0 minus 5. That is negative 5. So that last value at the end is always my y-intercept. I plot that, and now I have enough points to draw the picture. I'll draw the graph in green. So my graph looks like this. If I have the left side, I just reflect to get, or if I have the right side, I just reflect to get the left side, and voila, I have it graphed. If you want to check, you can always grab your calculator, go up to y equals, type in the original equation, like we had right here, 2x squared plus 3x minus 5. If you hit zoom in standard, it'll reset your graph back to the original settings, and that is what our picture looked like. It looks like it has the correct x-intercepts, and it also has the vertex. Correct. So it looks like we did it right. And that is how you can graph by factoring. I hope this helps. Please come in and see me if you have questions. Give it a practice.